This is AP Calculus. This is the final pretest 11 solutions. All right, so let's do this. We have number 1. You can say here, number 1. Find the area of R. Okay, so R. This thing is going to be equal to, and notice that R is being divided into 2 parts here, and everything here we can use a calculator. So we have to find where this intersection is. So I think it's 3.693. Did everyone get that? You basically graph these both on your graphing calculator to find this intersection point. And then you do second trace, intersect, enter, enter, enter. It'll get to this point. All right, so now that we know it's 3.693, I need to find this section, which is just this function. So it's going to be the integral between, and it starts at 1 here. So it's going to be integral between 1 and 3.693 of this function. This function is natural log of x. Natural log of x. And then don't forget our dx. Okay, that's the first section. Now I need to do the second section. The second section is going to start at 3.693, so integral between 3.693 and 5. And that function is 5 minus x, 5 minus x. Put parentheses around that, dx. Okay, when you do that on your calculator, should I do that on mine? I'll show us how to do that super fast. Oops. File, open recent, TI-83 plus. All right, so I'm going to do math 9, the integral of natural log of x. Oops, natural log of x. And that's from, or with respect to x, from 1 to 3.693. And I'm going to add that to math 9, integral of 5 minus x. Whoops, 5 minus x with respect to x from 3.693 to 5. Oh, I see what I did. I forgot. I said it, but I didn't get rid of it. I needed to delete those 2. There it goes. 2.986. All right, so far so good. Any questions up to now? Girls, good?
Yeah, we're good.
All right. So that was out of 3 points. And you got 1 point if you got the answer, 1 point if you got the, I think it's 1 point each if you got these 2. I don't remember exactly. I know it was out of 3 points. Okay, volume with R. So volume. So notice with volume, I think most of our mistakes were we didn't keep them separate. We have to rotate individually this section and individually, well, it's not rotating, it's individually this section is turning into squares and individually this section is turning into squares. So I basically take this function but square it, this function but square it. So the answer here is going to be integral between 1 and 3.693 of natural log of x. That function, nope, it's not being rotated, it's just square, yeah. If it was rotating, I would, yep. That's going to be dx. We all make mistakes. We're human.
You tried to do amen.
This is going to be integral between 3.693. And now because she made that mistake, she's not going to make the mistake on the test, right, Rosalie? So that mistake was a good thing.
Sure.
3.693 of 5 minus x. And that's going to be quantity squared dx. And there's our setup. So you got 2 points just right there. And to get that last point, you got to get the approximation. So if I come back over here, I can actually just go second enter to come back to the previous line and put parentheses here. So second insert, parentheses there. I need to put parentheses here. So second insert, parentheses there. And I'm going to square that. So second insert, or square there. And come down here to this function. I'm going to second insert, parentheses there. Second insert, parentheses squared there, and hit enter, and it should work. 2.784, is that correct?
That's pretty hardcore.
2.784. I can check the answer key as well. Oops. The answer key is right there. 2.784. Yeah, and again, the way that you answer this, you get 2 points if you did the integrands, 1 point for the answer, so that one was out of 3 as well. And part C. So part C was totally extra credit.
Wait, Mr. Sorry, on number B?
Letter B, yep.
Letter B. you do it separately because it's still under two different functions. That's why.
Exactly, yeah.
So then, if it was one where it's just under the one, like volume, you don't always separate it. Right?
So volume needs to be separated if those are two regions bounded by two different functions. So even when you're rotating, you'd be doing the same thing in terms of separating them, like this.
Okay.
All right, on to part C. So this one was out of 0 points. You can get a maximum of 3 out of this. How do you solve this? So in general, when you're creating a line, what you want to do, say you have some function like this. Let's create a function like this on your xy plane. And let's say we divided it like this. I know that we were trying to find a horizontal line, but let's pretend we found a vertical line. If you wanted to find the vertical line, what you do is you say, okay, that's k. You do the integral between 0 and k of the first function, or of f, and then you do the function between k and your ending point b of f. And then you say, okay, that is, those two are equal to each other because they need to be cut in half. Here's the problem. We can't do that because we're doing a horizontal line. We're finding some line that looks like this. So the trick for this one is treat it in terms of y. Basically twist this graph 90 degrees, and then we're doing the same thing. Twist this graph, so tilt your head 90 degrees and you're looking at it 90 degrees twisted. There we go. That's the graph we're really looking at. Everyone else did twist their heads. So let me get rid of this stuff. I want to teach us how to do this. So that means I need to write our equations x equals something. Instead of y equals, it's going to be x equals. So I have y equals natural log of x. So if it was y equals natural log of x, how do I undo natural log to both sides so we know how to undo this?
Don't you like go up like e?
Yeah, e to the y equals e to the natural log of x, and e to the natural log cancel out, so you're left with e to the y is equal to x. Now we have something in terms of x. We're good. So that's the first function.
Wait, can you slow down for 1 second?
Yes, I can. This part isn't too important. Again, you can probably miss this type of question and still get a 5 on the AP test if you're getting all the other ones correct. But it's just kind of nice to know how to do it.
Sorry.
How do I do the other y?
Why do you only choose y1?
Um,
Isn't there a 5?
yeah, I'm about to do that. Yep,
Oh.
you're correct. I have to do both of them. So y equals 5 minus x, so I have to do that one as well. Y equals 5 minus x. Solve for x, so x is equal to y minus 5, then divide by negative 1, so 5 minus y. It looks pretty similar. And if I'm tilting, if I'm looking at a tilted graph, that means this is going to be my top function, this is going to be my bottom function. So I'm going to say this top function minus the bottom function, and I'm going to divide it into 2 parts. So here we go. Here's your answer. So you're going to say the integral between, oh, and now we have to have different bounds. So we have to find the y coordinate here. We have to find this y coordinate here.
Why bound?
Because remember, our bounds are now, instead of our bounds being from 1 to 5, our bounds are going to be from 0 to whatever that point is.
And how do you know it's that point?
Well, that's where they intersect.
Oh. So,
You graph it.
So you can either graph it or you can just plug in 3.693 into either of these functions because that's where they intersect. So I'm going to plug it into this function here. So if I pull back up my calculator and I say 5 minus 3.693, it's 1.307. So I can come back over here, 1.307. And those are our bounds, 0 to 1.307. But somewhere in here there's a k, and that's where I'm going to divide up the integrals. I know it, and again, this is extra credit. You don't need to know this exactly. So it's going to be integral between 0 and k, and of these two functions subtracting each other. So it's going to be 5 minus y for that first function, minus e to the y, all of that d what?
dx?
No, not anymore.
Okay.
dy.
Oh.
Our variable is y. We're going to say that that side needs to be equal to the other side. It needs to be equal to integral between k and what?
1.370.
1.307 of the same thing. 5 minus y, all of that, minus e to the y, all of that dy. Done. If you did that, you would have got 3 points.
7 is height.
Yes.
So
There's
what can we get like 1 point out of?
you would get 1 point if you let's look at the scoring guide. So you get 1 point if you have the integrand. So 1 point if you get all of this integral set up. 1 point if you get the limits from 0 to k and from. Okay, they did theirs a little bit different. But if you get those limits set up on ours from 0 to k and k to 1.307, and you get 1 point if you just have the equation set up correctly. So it was
So
really
if
hard
I
to.
just got like 0 to k and then I accidentally did like our regular function.
No, because you need 0 to k and k to 1.307 or something that resembles the correct limits.
No, that's what I'm saying. Like, what if I got the limits but not the?
Oh yeah, you get a point then.
Oh, okay.
Perfect. All right, let's move on to number 2. Number 2,
How many points?
the first one was out of 6 because 3 and 3. So that was out of 6. Number 2, this is going to be out of 9. There is no extra credit. And again, extra credit only applies in my class. On the AP test, they do expect you to be able to solve those. Although I don't, because you can still get a 5 without them.
Imagine if they did have extra credit.
That would be
That would
awesome.
be so cool.
So write the equation for the line tangent. Oh, line tangent, as soon as I see that word, it's going to be y minus something equals something. The slope there, x minus something. I immediately write that down when I see line tangent. All right, so what is the x? X is 1/2.
I know.
What is the y? Well, again, everything is dealing with f. I'm only dealing with this function right here. So if I plug in 1/2, it's going to be 8 times 1/2, all of 1/2 to the power of 3. 1/2 to the power of 3 is 1/8. 8 times 1/8, as Joy said, is 1. And most of us got 1.
Yeah, they say it right up.
Yeah, they
there.
say it.
If you scroll up,
Scroll up.
Oh.
Oh my gosh, you scared me.
Yeah.
That is the much easier way of getting it. You can just look right there. Okay, thank you. Now to do the harder part, rather. This thing right here is f prime at 1/2. So first I need to find f prime, and then I need to plug in 1/2. So this is f. Therefore, f prime is going to be the derivative of 8x cubed. Multiply down. 8 times 3 is 24. X to the power of 2. Then I plug in 1/2. So 1/2 squared is what, girls?
1/4.
1/4. 1/4 of 24.
6.
There's your answer. Done. How many points was this guy out of?
2.
It was out of 2. You got 1 point if you got 6 and 1 point for the answer. So this was out of 2. If you got 6, that was 1 point. If you got the entire equation, that was at the other point. I graded a little bit too easy. I kind of gave you a point because you set up the equation. On the AP test, you won't get a point there.
Yeah, I was just
You
looking
didn't
at
give me
mine.
All right. So find the area of R. R.
Kill, it's okay.
So
Oh.
R is going to be the top equation minus bottom equation. There's no division here. There's no 2 separate integrals. So R is going to be top equation. So integral between 0 and 1/2. 1/2 is the x coordinate. Don't do the y coordinate. So 0 to 1/2 of top minus bottom. So you can just say f of x minus g of x. F of x minus g of x. All of that dx. Just from doing that, I believe you get points. You get 1 point if you do that. Okay, now I actually have to find the area.
On mine, you said that we needed to switch it.
Oh, I did mess up because sorry, yeah, it's the top here is not f of x. The top here is g of x. Yeah, you can get a point. Log that in your extra credit tracker. So sine of x comes from 0, and you know that sine generally looks like this.
are you
Sine.
gonna know it on the test? Like, I don't know.
You do need to know that on the test, yeah. Sine looks like that. Sine does not look like this. Sine does not look like that.
The other one is like a cosine graph.
Ah.
The other one is a cubic graph because it's a x
Are you
cubed.
okay, Gil?
But could it also be
Yeah,
cosine?
It could be cosine if it decided to
Thanks, Gil.
start here. So cosine looks like this.
Yeah, Gil.
Okay.
No.
Cosine starts at 1 and comes down.
Okay.
All right. So let's back up here. It should be g of x minus f of x, and I'm just going to write, because I'm eventually going to have to take this anyway, it's going to be sine pi x minus 8x cubed, all of that dx. All right, so let's do that. So I'm going to take the antiderivative of each of these. Antiderivative of sine, I have to be careful there, because whenever you do the antiderivative, you need to make sure that the inside, the derivative of the inside is what?
1.
1. Is the derivative of the inside 1?
No.
Therefore, we need to do what?
Tax man.
Exactly, yep.
No.
Taxman. So, let's get rid of those equal signs. So, taxman, that means I need a u, pi x. Who's the taxman?
Science.
Nope.
Just one.
1, it's on the outside. Derivative of the inside is pi. So 1 over pi is your fraction. 1 over pi is the fraction. So we're going to pay the taxman. We're going to have 1 over pi. And it's going to be 1 over pi sine pi of x. Let's go ahead and take the antiderivative of sine. Antiderivative of just sine is what?
Negative cos.
How do you know it's negative and not positive?
Anti.
Anti-same, exactly. Anti-same means change. You need to change the sign to a negative. So negative cosine and leave it pi x on the inside. Perfect. And so I'm going to write a giant equal sign. So this is our antiderivative. We need to do antiderivative right here too. Antiderivative of 8x cubed is what?
I have a question.
Go for it.
Don't you do taxman for 8x cubed?
The inside here is x.
2x to the 4th.
Even if it's 3x squared?
Well, that's why we always memorize what is the inside of the house. What house are you in? House is powerhouse. Inside of powerhouse is whatever is the base.
Oh, even, what about 8 in this case?
8 is the thing outside. 8 is the thing you're multiplying power. This is powerhouse right there.
Okay.
8 is being multiplied by powerhouse.
Literally, I would have gotten this. I even did my antiderivative right, but I had my interval wrong because I mixed up x and y.
All right, so x cubed is going to go up to x to the 4th. Divide down. 8 divided by 4. 2. That is going to be evaluation bar 0 to 1/2. All right, now we have to memorize our trigonometry. So when I plug in 1/2, it's going to be pi over 2. What is cosine pi over 2?
Isn't that 0?
It is 0. Pi over 2 is right here. Cosine is the x-coordinate. X-coordinate right there is 0. So all of that is going to be 0. So it's 0 minus, now we plug in 1/2 there. 1/2 to the power 4 is?
1/16.
Times 2 is?
1/8.
1/8. Good job. And now we're going to subtract. So now we're going to plug in 0. Cosine of 0 is 1 because we're right there. So I'm going to have 1. Sorry, it's 1 times this.
Isn't it pi times 1 over pi?
Where'd you get pi times?
Because in cos, it's pi times x.
It-
So since x is 1.
I think you're taking the derivative. You're taking dinner.
Because you plug in 0, so then if you multiply pi by 0, it'll be 0.
Wait, but once you plug in 1, because isn't cos of x 1?
So this whole thing right there is 1, I agree.
Oh, pi of x is 1 too?
No, so Joy just told you this too, that you're doing 0 times pi. Everything right there is 0.
Everything? Like, you're not-
Because you're plugging in 0 for x, 0 times pi is 0.
Well, I get that. I'm talking about like the 1/2 stuff. Wait, just kidding. 0.
This was plugging in 1/2 right there.
Okay,
Now we're
okay.
plugging in 0 right here. All right, so 1 times negative 1 over pi is negative 1 over pi. Plugging in 0 over here is 0, so minus 0. So negative 1/8 minus 1 over pi is negative 1/8 plus 1 over pi.
Please tell me we're done.
Done. I mean, you could combine like terms if you want to multiply the pi and pi, but I think we're good.
I think we're good. Yeah, it's good.
All right, C.
Wait, how many points was that out of?
So B, I believe, was out of 4 points. So out of 4. You got 1 point for setting up your integral. 1 point each for the antiderivative. So antiderivative of that one, 1 point, antiderivative of that one, 1 point, and 1 point if you found the answer.
I think the 0 to 1. It's just gonna be so mad. I could have run for it.
All right, part C. Write but do not evaluate volume when rotated around y equals 1. We've done these before, so volume, this is going to be equal to, well, y equals 1, where's that? Y equals 1 is right there. So right there. So the outside is going to be that bottom one. The outside is going to be 8x cubed. So it's going to be integral between 0 and 1/2. Oh, thank you. That's extra credit there, Joy. So multiply by pi. And it's going to be 8x cubed minus 1, all of that quantity squared, minus, and then it was sine of pi x, right? Sine of pi x minus 1. All of that quantity squared. The whole
Wait,
thing.
Mr. Sindel,
Yes.
didn't you once again flip them g of x minus f of x?
So now we're flipping them because we're rotating around the line y equals 1. So the
Oh,
outside
yeah, so it's still
is the
there.
bottom. Yeah. Perfect. And that's all we do. So how to score part C if you wanted to know. I gave you 1 point if you did the limits, so 0 to 1/2, and remembered pi. And I gave you 1 point apiece if you got these parts.
Yeah, I forgot the minus 1.
On to part 3. All right, so
Mr. Sindel,
yes.
how
Once again,
sometimes when you do volume, you
But I got 7
subtract
out of that.
the two like integrals. Wait, kill's too tall.
Sorry.
And then sometimes you add them. Like in that equation right there, you
Subtract.
subtracted them.
Yeah.
And then like in the one above,
Oh.
you added.
So you always think about it of the cross as the cross section. So the cross section was a circle and a circle. So I had to do the big circle minus the little circle to get that area. That's where the minus comes from. If the cross section was adding, it's because it comes from a square. This entire length, I have to add the function f plus g, and then I had to square it because this is also f plus g to get the area here. You're always looking at the cross section area. That's where the pluses and minuses come from. All right, good question. Yeah, I like that one. So now we're going to do this one. So we're going to find the area R here. So R is going to be equal to, yes.
Can I go to the bathroom? I understand this one.
Okay, yeah, go for it. 0 to 9. And I'm going to do top minus bottom. So it's going to be 6 minus 2 square root of x. I think most people got 100% on it. If you missed something, it was relatively minor in this one. So I'm going to go through this kind of fast. This thing, dx. So now that we have to do that, we're going to separate the integrals. So this is going to be equal to the integral between 0 and 9 of 6 plus the integral 0 to 9 of 2 square root of x. And I'm going to say x to the 1/2. Both of those dx. 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 You don't have to separate them, but it makes it easier because you don't have to worry about this 6 all of a sudden. So 9 minus 0 is 9. 9 times 6 is 54. So it's going to be 54 plus, now we don't have to worry about it. And then we're going to take the integral over here. So antiderivative, this is going to turn x to the power of 3/2. Multiply down, so 2/3 times 2 is 4/3. And evaluation bar between 0 and 9. So when I plug in 9, this is going to be 9 to the power of 1/2, which is 3 to the power of 3, which is 27, divided by 3, which is 9. 9 times 4 is 36, so it's going to be 54 plus 36. And then when I plug in 0, I get 0. So it's going to be 54 plus 36. And the answer...
I guess 54 minus 36.
I don't think... you're right, because I didn't copy down my sign here correctly. Yeah, that's a point there too.
Thank you.
So that's going to be minus 36. So 54 minus 36, and what is that? That's 18. Done. Part B. Right, but do not evaluate when rotate around y equals 7. So you're basically doing the same thing, but you're subtracting 7, and we're squaring them. So it's going to be the integral from where to where again? From 0 to 9.
You need pi.
Thank you, Joy. You keep catching me. Yeah, give yourself X credit. It's going to be, okay, y equals 7. So y equals 7 is going to be right there. So the outside function now is 2 square root of x. So 2 square root of x minus 7, quantity squared, and it's going to be minus 6 minus 7, quantity squared. All of that dx. All of that dx. Done. How to score yourself for these guys? I forgot to go number 1, but you give yourself 1 point if you got everything in the integrand correct, 1 point if you got the antiderivative correct, 1 point if you got 18. For number 2, you get 2 points each part of the integrand. So this part is 1 point, this part is 1 point, and if you did pi and 0 to 9, that's also 1 point. Let's go on to number 3, or part B. Wait, this should be part C. I don't know.
yeah.
That should be part C, whatever. We're doing squares here. So squares is going to be no pi. It's from 0 to 9. It's going to be 2.
Wait. Oh, just kidding. No.
Okay,
Sorry.
it's going to be 6 plus 2 square root of x. All that quantity squared
I thought it was minus.
dx. I think you just add them here, right? I'm pretty sure you add them. It is subtracting them. Why are we subtracting them?
I subtracted and I got it right.
Why? Like sometimes you subtract.
Oh, okay.
Yeah.
You're subtracting here because the cross section here, and sorry, that's my bad. The cross section here, to get this length, it's going to be f minus g. To get that length here is f minus g. And that length will pop out to make a square. So the square...
So sometimes it is plus?
Sometimes it is plus because the cross-section here is generated by this length. This length here is f minus g. Do we all see why that length is f minus g?
Yeah. But so then when would it be positive?
When would you ever add them?
Yeah.
The only time that you add them is when you have two functions, a function there and some function over there. If you have to divide it into two parts.
Okay.
So if there's a function on the left and a function on the right that intersect at the point, that's the only time that you add them.
But we know to add them. Okay, so pretty much always.
Yeah, so pretty much always subtract. I like that. So it's going to be 6 minus 2 square root of x. That quantity squared dx. Done. All right, on to the multiple choice. This is where most people started to flounder a little bit.
I floundered with mixing up x and y.
All right, so h prime of 1, that means I'm taking the derivative of h. I'm taking the derivative of this. Look, I have an outer. The outer is f. The inner is g. We know this. It's doubter times dinner. So doubter is f prime, and then we'll still have a g of x. We don't touch the inside. And then we need to multiply by dinner. Dinner is just g prime of x. All the x's here are 1, so it's 1 here, 1 here. So I need to do g of 1. G of 1 is 3. And then f prime of 3. F prime of 3 is negative 5. So this is equal to negative 5 times g prime of 1. G prime of 1 is negative 3. Negative 5 times negative 3 is positive 15. Doubter times dinner. Remember, whenever you do doubter, you still have the inner that hasn't been touched. Questions? That was technically number 4. I know I'm kind of out of order here because I stapled that last page on backwards.
It's okay.
Number 5. All right, each of these areas, A, B, and C, are all 2. That means I have a negative 2 there, a positive 2 there, and a negative 2 there. When I add all of those up, I get a negative 2. But wait a sec, the answer is not negative 2 because I'm not finding the integral between negative 3 and 3 of f of x. I'm finding the integral of negative 3 to 3 of f of x plus 1. So this thing gets rewritten as integral between negative 3 and 3 of f of x dx plus integral between negative 3 and 3 of 1 dx. What we just found, negative 2 here, is this thing. This thing is negative 2, but we haven't found the integral between negative 3 and 3 of 1. To do that, you use the trick for integral of a constant, 3 minus minus 3, or 3 minus negative 3, that's 6 times whatever number you have there. 6 times 1 is 6. And I need to add those together to get our final answer of 4.
I'm so dumb. I just added 1 to negative 2. Like.
Yeah.
Oh.
You have to do that. You have to do that repeatedly for each step. Yeah. You're close.
I don't even know what I did actually.
Number 6. All right. So we know that A means acceleration, V means velocity. We're looking for average velocity, and this is something that we just need to have memorized. Average of anything. This will always be equal to 1 over b minus a integral from a to b of anything. All right, so we're trying to find the average of velocity. Replace anything with velocity. So now this is going to be vt. Average vt is going to be equal to the integral bounds of vt. Integral bounds are from 0 to 8, so I'm looking for 8 minus 0, 1/8. So the correct answer is here. It goes 1/8 from 0 to 8, and we plug in vt for the anything. I think this one was missed just because we forgot the definition of what average value means. Questions on number 6 or anything before number 6?
When do we use the absolute value? That's total distance.
Great question. When do we use absolute value? Someone else answer it.
Total distance.
Total, yeah.
Change in distance.
Yeah, total distance traveled. Total displacement is VT. Total distance traveled is absolute value. Thank you, Sophia. Number 7. All right, left Riemann sum. Again, left Riemann sum, if you're thinking of a gun, the handle of the gun is left. And here you're looking at the change in the interval. The change from 2 to 3 is 1. So you do 1 times 6, which is 6. The change between 3 and 5 is 2. 2 times negative 2 is negative 4. Between 5 and 8, the change is 3. 3 times negative 1 is negative 3. Change between 8 and 13 is 5. 5 times 3 is 15. add all these up, what do we get? So 6 minus 4 is 2, 2 minus 3 is -1, -1 plus 15 is 14. Correct answer is B.
So you never average the top?
Never average the top. You only average the bottom when?
The mid. Yeah.
Trapezoidal.
Oh, sorry, it's not trapezoidal. Is it trapezoidal? Is it mid?
I think it's midpoint.
It's trapezoidal, actually. Midpoint, you only use every other. Midpoint, you use that one. Oop. So if I delete that, you use that one and that one. That's midpoint. Trapezoidal, you take the average. Average,
Midpoint
average,
is the
average,
trap
average
and
is
you multiply times the middle. Trapezoidal, you take the average.
exactly.
Think of the word.
Yeah, perfect. You have the understanding. And last, and probably one of the most missed questions, number 8. All right, so for this one, you need to think of the area. So the integral, this thing represents area, so f of x is going to represent the change as area changes. So this thing right here, area. So notice that between A and B, there's a positive area, and between B and C, there's a negative area. That means I should be changing positively. I should be increasing between A and B, and I should be decreasing between B and C. And notice at B, you should be neither increasing nor decreasing. All right, so let's look at A and B. It's increasing, B and C is decreasing. That is a sharp corner, and there's no discontinuity in this function, so it should be a smooth area, so it can't be A. And that's a little bit subtle, but it is indeed correct. If I have a smooth area, I'll have a smooth change up here, so it can't be A. B, I'm increasing, but then all of a sudden I'm decreasing down here. I need to be always increasing between A and B, so it can't be B. For C, I'm increasing between here and here, but I'm decreasing right here, so that's not quite right, so it can't be C. D, I'm immediately decreasing, so that doesn't even make sense. And E, I'm increasing between A and B, and look, I stop increasing at B, I'm neither increasing nor decreasing, then all of a sudden I'm starting to decrease at C until I get back to 0. I'm neither increasing nor decreasing at C, which also matches up because I have another 0 over there. So the correct answer here is E.